Okay, so I'm probably just gonna let him log into my Zoom account and then I can log off. Do you guys know if two people can be logged in to the account at once, or should I drop off?
I think so. Two people can log in at the same time. I use two accounts.
Okay, yeah, two different computers. Okay, sure, we'll try for that.
Cool. Thank you.
Sure.
So while we wait, I guess, yeah, for people who are joining me a little around now and who are waiting on YouTube, thank you for coming. Just hold on for a little bit. Julian is joining, and soon, and we will get to hear from him soon.
Hi, how are you doing?
Hi, Julian. Thank you for being able to make it. Sorry about any inconvenience caused.
No problem. You guys can hear me okay?
Yes.
Okay, you're listed as Samantha DeMeo, but I will just log off and let you guys proceed. Have a good one, guys. Good luck.
Yeah, thank you, Sam.
No problem. Okay.
Yeah, so welcome to the meeting. Julian, thank you so much for taking out the time to come and talk to us about your team at Amazon and for giving this wonderful talk. So let me briefly introduce Julian. So he is the Director and Chief Scientist for last mile logistics at Amazon, and he leads a team of researchers and engineers that design and build the decision support systems used to run Amazon last mile worldwide operations. So he got a Bachelor's of Science in Industrial Engineering from Universidad de los Andes, Bogota, and a master's in industrial engineering from the same university, and a PhD in operations research from the University of Miami. And he actually started out his career as a professor teaching optimization, probability, stochastic processes, and statistics. And after finishing his PhD, he joined Caleb Technologies and which is a company focused on building optimization systems for aviation. And while at Caleb, he traveled around the world across 5 continents and implementing these technologies to build carriers of all types and sizes, and they even won the prestigious Edelman Prize based on irregular operations technology that was used by Continental Airlines for recovery from September 11 disruption, which was the largest disruption in the history of aviation. And prior to joining Amazon, Julian spent 8 years leading all the operations and optimization technology for United Airlines. And he was in charge of leading the largest merger in the aviation industry, and built out state-of-art and fully automated their command center at the Willis Tower in Chicago. And he has published extensively and holds over 25 patents in aviation and logistic related topics. I will let Julian talk more about his life at Amazon and what he does and all of that. So yeah, thank you, Julian. Over to you.
Well, thank you so much. Thank you so much for the invitation, and it's always a pleasure to talk to students. And so I'm glad we're having this audience. I'm going to share my computer here. Let me see if I can come and share this. You guys see now the presentation, I believe. Is that right?
Yeah, I think now we are able to see this.
You see some the large scale last mile operations front end on there?
Yes. Cool. Yes.
I'll get it started. Well, yeah, I lead, the Amazon last mile, from the product and science perspective, and This is kind of a pretty big journey with respect to Amazon. We started doing last mile deliveries, almost 8 years ago, and now we have over 8 billion deliveries per year. So it's a pretty massive endeavor. We are in over 20 countries, and we're kind of expanding as we speak. But today's presentations are gonna do 3 things. In the first thing we're gonna talk about is how the last mile fits within the overall supply chain of Amazon. So kind of to put the last mile in context. And then we're gonna talk about 2 topics. The first one is what have been the fundamental changes that have happened over the last decade or so that have elevated the role of the last mile, and basically why is last mile so critical right now. And then we're going to talk about, what is that it takes to run, large scale and efficient last mile operations. And then I'm happy to address, any questions. So, let's talk first about, how the last mile fits within the entire supply chain. In Amazon, we divide the supply chain into 3 parts, what we call the first mile, the middle mile, and the last mile. So let me kind of walk you through an example of how this works. Let's say I live in Austin, Texas. I imagine many of you do, since you kind of attend UT, but anyways, let's decide that I decide to buy a computer. So I can go to, the app and search for the computer, and I decide, the particular computer that I'm gonna buy, and I buy it. So the first thing that we're gonna do is we're gonna identify where the computer needs to be sourced from. So we have around 70 fulfillment centers in the United States, spread across the entire nation, but not every fulfillment center have all the products. So we have a lot of intelligence about the position of products based on buying behaviors and so on. But let's say that this computer is we can source it from New York. So that's the first thing that we're gonna define, and then we'll send the order to the New York fulfillment center. They're gonna pick up the computer from the shelves, they're gonna pack it, and they're gonna put it in a box, ready to be shipped to my house. So that's what we call the first mile. But then they're gonna have to send the computer first to Texas. So that computer is likely gonna be on an airplane from New York to Dallas. In Dallas, it's gonna go to a source center. And in a source center, we're gonna get shipments from many other fulfillment centers around the nation, with all packages that are gonna go across Texas. And then all the packages that go to Austin is going to be put on a line haul that will take that computer from Dallas to Austin to a delivery station. So all the journey from New York to Austin is what we call the middle mile. Now, the delivery station is roughly 15 miles away from my house. And basically, when the package gets to the delivery station, it's gonna be sorted with other packages into a route. And then that route is gonna end up, arriving to my doorstep at my house and finally getting me a computer. So the journey from New York to my house is 1,800 miles. But the journey from the delivery center to my house is only 15 miles. However, those 15 miles account for 60% of the cost of delivering that package. And this has to do with the economies of the scale. We can put thousands of packages in an airplane and thousands of packages in a line haul, but in a van in the last mile, we can put roughly between 200 to 250 packages. So the cost of delivering the last mile is a lot, more expensive than in any other part of the supply chain. And when you can imagine with 8 billion packages, where 60% of the cost is the last mile, obviously we have to put a lot of emphasis in making sure that we can fully optimize, that part of the journey. So that's kind of to contextualize where the last mile fits, within Amazon. But now let's talk first about, what has been the 5 fundamental changes that have elevated the role of the last mile. And let's talk first about, the shift in the retail buying process. The retail buying process encompasses 4 steps. What we call discovery. Discovery means is where you're trying to figure out what you want to buy. You're trying to say, well, maybe I want to get some clothes, and you look at some magazines or TV or internet, whatever, and you say, cool, I want to buy a jacket. That's kind of the discovery. Then you actually go and search for the jacket. So there's thousands of different jackets, and actually you go and search for the one that you want to buy. Then you buy it, and then you need to finally get it. So a lot of you are very young. I'm an older guy. That I was born and raised in a traditional retail. In the traditional retail, the discovery will be, via propaganda ads in the TV or magazines, and then you actually will go to a store or to a mall, and then you will look around. Finally, you will identify the store where you want to buy it. Then will you go to the aisle, you will pick a couple of jackets, and then you will pick one, go to the checkout, pay it, and then basically take it with you to the house. That was kind of really the traditional, way of doing it. When you had to buy a sofa, then you will probably do the same, and they will have specialized carriers that will bring the sofa to your house. But a lot of things have changed. The first thing that changed when the introduction of the e-commerce, and basically was the internet boom started, and people started launching websites, and there was kind of some transformation from a total on-site retail experience to different companies having their own websites to advertise their products, and then people will go to the retail process within the specific websites. That was a good thing, but it was not really never big. Even when people had their own website, generally a lot of the sales will be driven on physical stores. So, but the big change happened when this little thing show up, and I think this little thing is especially the iPhone, because the iPhone was basically the first, of the smartphones, and when the iPhone show up, it was about the same time where Amazon and eBay were growing. And, Amazon and eBay were kind of the first marketplaces. And the combination of the iPhone and the marketplaces became very, very, very powerful. And became very powerful for multiple reasons. The first one is that it really kind of increased in a substantial manner, the sales that were kind of done online. And when you do an online sale, it immediately means that somebody have to take the package to your house, which obviously that's kind of the role of the last mile. But, that impact happened because, when you have an iPhone, you have immediately millions of, of products, and the marketplace, you have a lot of products in the same screen, right? Different when you have to go to a different website per product, but now you go to Amazon or eBay or whatever of these marketplaces. Now you have, everything that you want to buy in a single place. Also, you have so many people that are trained on the buying process. So people in a way don't even need training. Now babies, grew up, and they can buy in Amazon faster than what they can walk. I mean, it's unbelievable, how, these applications are so easy that, people don't need training. You can have a grandpa or a baby or whatever, and everybody can go through, an Amazon 3 clicks and buy any product. So basically the fact that you don't need, people to be trained is a big plus. And obviously that this has diminished the role of the retail stores in a substantial manner. And obviously it also has exacerbated the need for delivering the products directly to the people's house. Now, during COVID, it has actually, had a very interesting impact because, we had, and many companies have a lot of penetration, via the apps and online, before COVID, but COVID really transformed in a substantial manner many other habits. If you see about, the buying behaviors for restaurants and for food and for, groceries and even, other type of, products have, magnified tremendously because of COVID, because COVID basically forced the people that were not believers in the system to be, well, they have to work with the system. So now, everybody's kind of buying online. But what this means is that now we have a huge density. Density basically means is the number of packages that you have to deliver, in a particular territory. So let's say square mile or things like that. And when you have high density, that automatically means a low cost for the last mile. Why? Because basically you have a driver that go to a block, and if you can deliver 3 packages in the same block, well, it's obviously a lot less expensive that you have to deliver, a package, every other, mile. So, when you have the opportunity to increase the density, then you can operate, very efficient, last mile operations. So, that's kind of gives you a flavor of, some of the changes that have happened, in the last mile, that, is kind of growing, the need to be able to be really good on this area. This chart shows you the retail e-commerce sales, worldwide, and this is not millions, billions, this is trillions of dollars. So this is big numbers. So, when you see, these numbers, you can see, how fast, this is growing. And let me kind of translate, with an example of what this means for the last mile. Austin is a relatively small city in the United States. It has around 1.3 million people. In Austin, we deliver 60,000 packages per day. So when you do the math and you say, you know, I have 1.3 million people, there is an average of 3 or 4 people per house, and you have 60,000 deliveries. That means that we are delivering a package every other block, every day in Austin. That's pretty big. We visit the entire grid of the city every single day. So, and that happens, you know, not only in Austin, that happens in LA, that happens in Chicago, that happens in Miami, pretty much everywhere. So it's a pretty, you know, pretty large, you know, operations. So that's the first thing is, you know, there has been a shift in the retail process. The second thing is that the product definition now includes an element of service. And this is what people call instant gratification. So what this means is that, you know, it's not the same two products in which one, you know, I can get today and another one I can get next week. Those two products are two different things and have two different prices. And now people are getting to appreciate a lot, you know, the speed. And, you know, initially people were happy with delivering within a couple of weeks, then a couple of days, then next day, then same day. And now people want to get to deliver this in a couple of hours. And, you know, when I started this journey in the last mile, I thought that, well, you know, yeah, that's cool. But, you know, I think that this speed of delivery is something probably that the millennials is the only people that they really want to get this. And I had a very interesting experience the other day. You know, people talk a lot about Amazon. You know, and everywhere I go, and when they know that I work for Amazon, they always speak about Amazon. So it's kind of interesting because you know, we work long hours, and when you go somewhere else, people still want to talk about Amazon. So it's like, but you know, I went to church to a church meeting the other day, and the last thing I was planning to do was to talk about Amazon in church, right? So there was this guy, around 75-year-old guy, and very nice. And then he said, hey, you know, you work for Amazon? Yes. I said, oh, Amazon is so great. And I said, oh my God, here we go in a church meeting. I said, what happened? And then he tells me, well, you know, I'm gonna give you my experience. And I said, well, cool. He said, I was in Costco and I was kind of doing my shopping on a Saturday morning. And he said, well, he wanted to buy a printer. And so he goes and to the place of the printers and look at the printer and decided to, okay, this is the printer that I'm gonna buy, and put it in the cart. So he was kind of, you know, in Costco, and he said, well, you know, I wanna look at the price, you know, in Amazon. So he went to the app and looked at the price in Amazon. It was about the same that the price in Costco, and he said 2-hour delivery. And the guy said, a printer, 2-hour delivery, what do you mean? I said, I'm gonna carry this printer, you know. So he decided to take the printer out of his cart, continue the shopping in Costco, go to checkout, get to his house, and the printer was in front of the door. He said, from that day, I never go to Costco anymore. And this is a 10-year-old guy that basically, you know, you gotta assume that he's already used to many processes, and it's gonna be very hard to change, but no. So the point here on the instant gratification is that once you raise the bar on this kind of service, it's very hard to get away from that. So the people or the companies that are able to raise the bar at that level, you know, once people experience that level, then they don't accept anything else. And so it's very hard to compete for other companies once somebody has put the bar so high. So I'm gonna show you during this presentation a couple of videos. This one is for Prime Now. Let me put it here. Hopefully you can hear it on your end.
Amazon Prime Now. Free 2-hour delivery on thousands of items.
You can hear it?
Shop for daily essentials like home basics, electronics, toys, home entertainment, and more. To begin, download the Amazon Prime Now app on your smartphone and log in using your existing Amazon account. Add items directly to your shopping cart from search results. Choose free 2-hour delivery or select 1-hour delivery for $7.99 from morning to night. It's Prime Now, exclusively for Amazon Prime members.
So this is one of the services that we have. It's available in many cities where now we do, you know, 2-hour deliveries. You know, clearly 2-hour deliveries, you know, cannot be for any product. So we have, you know, around 100,000 SKUs that are kind of the products that we believe people will need to order in 2 hours. right? So if you have something that is very specific, you're not likely to get it in that particular service. You got it, like to get it in the Amazon.com. So, obviously speed also has the context of what products make sense for that speed. The point is that, we believe that, not only Amazon, but all the competitors are going to continue to raise the bar on speed, which is also going to, generate additional challenges for the last mile, because, it's one thing that when I have 8 hours to deliver the package, a very different thing when I have 2 hours to deliver a package. So the third thing is that have changed the last mile is that the last mile driver is now the only touch point with the customer. What do I mean by this? Again, back to the retail process, when you used to go to a place and you have FaceTime and ask the people, hey, what is the jacket? Can you bring me the jackets in blue, or you will pay with somebody? So there were many people that participated in your experience and that have the opportunity to influence that experience. But if you go to Amazon today, or pretty much to anybody, you don't see anybody. You don't talk to anybody. You just go to an app. Hopefully the app is really good. You interact with the app, you do kind of 3 clicks and then you buy, and that's it. So you never have to interact with anybody. And the only person that actually shows up in your door is the driver. So this is the only person in the entire supply chain, from the computer getting in New York that is touched by a lot of people because they have to pick it from the racks, they have to deliver it in an airplane, they have to deliver it in a 9-hole, they have to be sorted in a delivery station, and finally get into your house. Oh, a lot of people participated in that, but you never see anybody. The only person that you see is the driver. So this is critical because, now the experience that driver will provide to the customer is as good as the experience that we provide to the driver. So this is an area where we put a lot of focus, because we know that if we don't set up that driver for success, he's gonna provide a very poor experience for the customer, and that experience is basically the only experience that the customer is gonna feel from Amazon. So he's basically in control of that experience. So obviously this means that we need to have competitive pay. This means that we need to make sure that we have feasible workload for the guy, because if we tell him, you go and work for 15 hours, well, guess what? The first couple of hours is good. In the last couple of hours, it's not gonna be that good. We also need to make sure that we provide affinity to the area of delivery. What is this? If delivery is hard, and if you go and deliver every day in the same house, then it becomes easy, because you know the house, you know the name of the person, you know exactly where to put the package. But if every day I randomize you and put you in a different part of the city, then you get frustrated every day because you're learning every day a new address. So make sure that people get familiarity where the places where they deliver is a critical part of the job. Then obviously providing a friendly app and providing great driving support whenever they don't know, how to locate a house, or there is an issue with the customer, make sure that somebody's on the line to help you resolve the problem. Is a big part of enabling, the driver experience. I'll show you a video of what happens, and it's kind of a funny video, but but basically, if you don't provide the right service for the driver and the right experience for the driver ultimately will do things that you don't want him to do. So this is just kind of a click through of a movie that you probably have seen before. So that is exactly what we don't want a driver to do. But if we don't put him in a position for success, he probably will do something like that. So the next thing is that now technology is enabling a large number of options to do aggregation of deliveries. So we already kind of talk that, density is the king. If we have good density in the last mile, we are able to reduce the cost and be very efficient. So now there are many, many ways of how to build density. So, you may have seen the Amazon lockers. So Amazon lockers, basically, you have a locker with 50 lockers, then basically one driver go in one stop and put the 50 packages in one stop, as opposed to visit 50 different houses. Now we have the opportunity to also do delivery within the vehicles. So this is very important, in hospitals and universities. When people subscribe to the delivery within the vehicles, it's easier for us because we go to a parking lot in a hospital and do deliveries in 50 different vehicles and get out without even visiting the offices of the hospital or the houses or whatever the case may be. So in a way, there is many flavors of these things that are popping up that really kind of allow us to do a much better consolidation of packages. And when we do that, we increase density. When we increase density, we reduce the cost of delivery. So, we have also done, a lot of deals with multiple car manufacturers that are kind of helping us in this journey. I'll show you, some of that.
In recent times, Volvo Cars has made great strides in digital consumer services, with the simple goal of making life easier for its customers. Now, the company is expanding its digital offering by partnering with Amazon to offer in-car delivery in the United States. In-car delivery, in partnership with Amazon Key, is rolled out nationwide in dozens of cities around the country.
We've been running in-car delivery in Europe since 2015. We believe that receiving a package should be as easy as ordering one. This offer will be available to all Volvo On Call subscribers and Amazon Prime members.
Receiving your Amazon delivery in your Volvo is simple. Just shop on Amazon and select in-car delivery at checkout to complete your order. On the day your packages will arrive, an authorized delivery driver locates your Volvo and places the package inside. You will receive a notification once the process is complete.
Simplification of experience and putting control directly in the hands of consumers are two things that are very central to Volvo's digital vision. We're very enthusiastic about realizing this vision. It'll delight customers and grow our business in the process.
And we have done that with not only with Volvo, but with many of the other big manufacturers. So the five, change that is quite big is that the gig economy, has become a key enabler for large and efficient, large mile operations. The Uber is kind of what people know as about the gig economy, right? And there are many examples, on Uber. But we have a service, similar to Uber, but it's not for people, getting trips from A to B. Is actually to deliver packages. We call it Amazon Flex. It's a quite big program. We pretty much in all these cities in the United States and in all the main cities in Europe, Japan, and India. And so, similar to Uber, people will subscribe to the app and, they will come and do deliveries for us. So they go to a delivery station, they pick up X number of packages, and then they basically go and deliver those packages, throughout the day. So this is great, and it has a lot of positive things. One is that in a way you have unlimited drivers. Getting professional drivers is becoming very hard because there are not that many professional drivers anymore. Within FedEx and UPS and now Amazon and and the other guys, we're running out of professional delivery drivers. So now we have to rely on capacity that is coming from somewhere else. So, putting the Flex program has allowed us to really unblock capacity, and now pretty much anybody can deliver a package for Amazon. It also allows us to lower the cost because, it's a different business model where, people subscribe, they bring their phone and the vehicle. So kind of the arrangement is different, that you have to pay for, trucks on a fixed, cost basis and so on. So it allows us to really save money on the delivery. And it also allows us to deliver faster. Why? Because personal vehicles are small, So we cannot have a route of 9 hours in a personal vehicle. We cannot put 200 packages in a personal vehicle. So what we do is that in a personal vehicle, let's say we put 40 packages. Well, then guess what? So as opposed to have a 10-hour route, we may have 7 short routes, but then the time for delivery for all those packages is within 3 hours. So nobody gets a delivery in 9 hours. Everybody gets the delivery within 3 hours. So it also allows us to reduce the delivery time. However, it doesn't come for free. There are multiple challenges to do this. The first one, and going back to the experience, is that when you do a crowdsourcing program, you cannot train anybody. So if somebody subscribes and they want to come and do deliveries for you, then they need to be able to come and the app itself should tell them exactly what to do. So you have people that are high tech and students that they know it all and they can come and obviously do it really fast. But you have grandpas that are retired that they also want to be part of Amazon Flex. You have soccer moms. So now you need to have an experience that will work for anybody regardless of the levels of sophistication with respect to technology. And that is super hard because in deliveries, 80% of the deliveries are easy. You go to a big house where it's very hard to miss it. Well, good, anybody can do that delivery. But if you go to a set of complex, an apartment complex, where you have so many buildings and there are so many streets within that, then it may take you a while to deliver. And if you don't provide the right experience, the person is going to get frustrated, very fast. So a big part of what we do is to enable an experience in a way that anybody can do it without any type of training. And obviously that's really hard to accomplish. The other thing that happens in the gig economy is we need to keep the people engaged because they have, a lot of options. The gig economy by definition are people that are going to do multiple things at the same time. So a flex driver is the same Uber driver, the same Lyft driver. So he may go and do an Uber ride in the morning, then come and 3 hours for Amazon Flex, then do, Lyft in the afternoon. So these people, they have options. On the day, they say, well, how much, is paying Amazon today for this block? What is the ride that is popping up for the airport in Uber and so on? And they're going to go after what is the best for them, right? So once you are going to the gig economy, one of the challenges, even though you have unlimited capacity, then you're also competing for that capacity with other people. And us, we are so focused on making sure that we deliver the package at the time that the customer is expecting. So if I need a driver for 3 hours now, I need it now. I don't need it in 2 hours because I may fail the customer promise. So the question is, well, at some point in time, we also have to play with pricing. So we say, hey, we're going to pay you $18 per hour. It doesn't pop up. Now we say, okay, now we're going to pay you $20 per hour. And then at some point in time, we say, we pay you $40 per hour, and then we eventually get it, right? So there is also, it has a lot of pricing components to make sure that we attract the right people at the right time. So that's kind of the big changes that have happened over the last decade that really kind of have changed, how we do last mile deliveries. And now let's turn to kind of talk about what it takes to do last mile delivery in an efficient manner. And the first thing is, we need to define, a clear goal and clear KPIs. And let me walk you through this. This is what is in the screen is the goal for the last mile in Amazon. And what I have highlighted in blue are critical words of that goal. So this one is enable last mile, scale, while ensuring packages are delivered, to end customers at the right location, on time, and at the first attempt. So let me kind of piecemeal this for you. Scale. Amazon, is, again, is over 8 billion, deliveries per year. Is growing. Next year, we're going to get to 10. So the scale is a big part of what we do. So anything that my team and anybody in Amazon does, it needs to be focused on a scale. So let's talk about scientists in general. There are many scientists that can come up with the right algorithm to solve a problem. But if that algorithm is good to solve the problem for 1,000 packages, I say it doesn't help me. If that algorithm is good to solve for 20,000 packages, doesn't help me. So the algorithms that we build needs to be able to scale to 100, 200, 300,000 packages per city. If it doesn't scale to that way, it doesn't really matter how good or how sophisticated it is. It's not going to help me, right? So scale is a key part of what we do. So anybody that comes to the Amazon team, they need to understand that they have to think big and super big. Anything that we do is at the scale. Small things here we don't touch. because we know that we cannot, we cannot expand it. The other thing is that, we want to deliver to the end customers, right? So we want to make sure that, we're super customer focused, and we want to make sure that the customer have the right experience. So if I tell you I'm going to deliver to the door of your house, I'd better not deliver, half a block from your house. So we want to make sure that actually, I put it in your doorstep. And getting the location of a house, it sounds like easy, but it's probably the most complex part of our job, because you know the location of your house because you rented the house, or you bought the house and you know exactly where it is. Now telling that computer where that house is a whole different story. Even if you tell me your address, or you go to Google Maps or whatever it is, the address is one thing, but really at the end of the day, you have to map that address to a physical point in the air. That's what we call the geocode. There is not a national repository of geocodes. In fact, if I put a survey on this call about how many of you know the geocode of your house, I'd probably tell you that 0 of you will know the geocode of your house. So, you don't, oh, where do you live? Oh, my geocode is 3544. It just doesn't happen. So we have the art of translating a physical address into really a physical point in the air, which is a very challenging problem. And then obviously we want to be able to make sure that we deliver the package when we told the customer that was package was due and on the first attempt. What I mean is that if I don't get to deliver the package in the first attempt, immediately I double the cost of the package, because you have to come next day to try to deliver the package. Immediately the cost has doubled. So part of our job is to make sure that we deliver it, only once. So putting a goal, people say, oh, it's easy. Well, it's not that easy. You need to have the right elements of a goal. You need to be as detailed as this. So that's basically what, we put a lot of focus in making sure that we cover all the angles to make sure that at the end of the day, we're going to be able to hit the goals that we put in place. And there is a difference between a goal like this and the KPIs. So when we talk about the KPIs, we have weekly meetings where we review thousands of metrics, for all the countries every week. But generally, those metrics are divided, into 5 categories. We have safety metrics. For example, we want to make sure that we track the number of injuries that people have on road. We have delivery quality metrics. For example, if I tell you that your package was going to be there by 4 and that package got there at 4:05, for us, it's a defect. We failed you because we told you at 4, right? The driver experience. So, for example, if we measure the consistency of the assignments, if the blocks that you deliver, every day, is very different, or you deliver, to different areas of the city every day, that's for us, that's a defect. Obviously, the cost. And the last part is very critical, and is what we call the inputs quality. A lot of people focus on the output. And we believe in Amazon that focusing on the input is as critical as focusing on the output. And I'm gonna give you a couple of examples, later in this presentation. But if we go and do a route, and we say that route is gonna take 9 hours, that route has some assumptions. Basically, as I have some assumptions on the transit times between A to B, the service time at every house, and so on, right? So at the end of the day, if the route fails, and now the guy didn't take 9 hours and took 10 hours, well, not necessarily was that the routing logic was bad. It could be that the inputs were bad. Meaning, did we forecast the transit times the right way? Maybe not. Did we forecast or estimate the service times the right way? Maybe not. So, part of this is to make sure that the inputs, are good. Otherwise, the output is going to be garbage. So, we focus a lot on making sure that the quality of the inputs is at the right level. The other thing is to make sure that you have the right decision support systems. So, in the last mile, there is many decision support systems. On one end, we have topology. Topology basically decides, where are we going to put the delivery stations? What is the jurisdiction of those delivery stations? We are so big that sometimes, like in LA, we may have 4 different delivery stations. So one of the questions will be, well, how do we divide LA? If I have 4 delivery stations, which delivery station is going to, deliver to each neighborhood? Well, how is that mapping work? So that's basically what we call topology. Then we have capacity planning. We need to make sure that we have enough people at the station to sort packages and so on, and on road to be able to kind of fulfill the promise of the customers. And this is really what drives a lot of the cost, because on one end, if you overshoot and you schedule more people than what you need, you're gonna end up paying a lot of money that you don't have to. But if you undershoot, then you don't have enough people to deliver, and basically we're gonna break the customer promise. So there is always a fine line between the two of them, but we need to be super precise to make sure that we can deliver to the customer promise, but at the right cost. Then we have the driver scheduling that, once we know how many people we need, then we need to really map people with tasks. So now we need to say, John, you come next Tuesday from 8 o'clock to 5 p.m. or whatever it is, right? So that is kind of the scheduling part. And that is basically, topology, capacity planning, and driver scheduling is what happens before day of operations. Now, on day of operations, there is a lot of other things that happen. So the first thing is sortation. So we need to come up with a sortation plan. So when we have packages coming to Austin, they come in multiple line hauls from different source centers. One may be coming from Houston, one may be coming from Dallas, one may be coming from San Antonio, whatever the case may be. And those trucks do not come at the same time. They come maybe from 9 p.m., 11 p.m., 2 a.m., and so on. So they come, in Austin, we get around 20 line hauls in a night, and for deliveries for the next day. So part of the challenge is that the classical routing systems do not work here. Because in a classical routing application, you assume that you have all the packages and you can go and just basically do routing and that's your solution. But here, it's a little bit more complex like that, because when the first line haul arrives, I cannot park the line haul outside the facility and say, oh, you wait until the other 5 line hauls arrive. I have to start, unloading the package and sort them. But now I have to sort them, but I don't know where the other packages are going to come from, right? So there is this whole sortation logic of how are we going to sort packages into bags at the delivery station so that we can have continuous operations in a way. The first line haul comes, we sort. The second one line haul, it sorts, and so on. And then once we have all the volume sorted, then we really call and do routing. So we have, the vehicle routing problem is kind of a different version of that, because now we're routing packages that have already been sorted, not individual packages, but the bags themselves that we have, predefined in the sortation plan. Then we have the assignment and dispatch, and basically this is kind of, okay, now I have, 20 drivers and I have 20 routes, and then I have to assign John to route 3 and Thomas to route 2 and so on. And then dispatch, which basically means, in the facility, we have different staging locations and different dispatch times and how we're going to organize all the traffic, going out. Then the drivers go on road and a lot of things happen, right? The guy can get a flat tire, or maybe we plan an 8-hour route that now, 4 hours into a route, the guy has only completed 25% of the packages. Clearly, he's not going to complete the route. So now we are starting this rescue business. How are we going to make sure that we have to deliver all the packages for the day? So people that are lagging behind are going to have to be rescued by other drivers that are going above, and beyond what they have to do, and so on. So we have the real-time, replanning mechanism to do this. Now, across all these systems, we also have multiple machine learning models that basically compute the inputs. As I said, garbage in, garbage out. So most of these systems work on very advanced, machine learning models that determine what those inputs for those systems will be. And I'm going to show you a couple of examples about that. So when we talk about, the network, in Amazon, we have multiple networks, because, this slide that I show you here, it sounds like one, but the reality is that we have so many different types of operations that we have to do this for many things. One thing is Prime Now, that is 2-hour deliveries. The other one is the ground boxes, that is kind of generally what you get in your house, that is, 8-hour deliveries. So all of them have a whole different network. So, and there is variations of how we do, each one of these activities. But, in general, we have 2 types of networks. The first one is what we call the high volume. And these are the long routes. This is where we have generally longer windows to deliver and so on. And then we have what we call the specialized or the ultra fast network. And this is basically where we do, like, for example, Whole Foods is part of the ultra-fast network. We do 2-hour deliveries for Whole Foods. We do 2-hour deliveries for Prime Now. And obviously the density is lower, the routes are shorter, and so on. So one, generally we do it once per day. The other one, we do it many times per day. In one, generally we do a combination of flex and trucks. In the other one, we use personal vehicles, we use bicycles, we use walkers. And so there is kind of different flavors on these two. But at the high level for the high volume network, this is kind of what we do. We first partition the geography into geos, into smaller geos. So let's assume, like, for example, that are city blocks. So I can partition, a city into city blocks, and then we compute a trace across all the different city blocks. So basically, we run a TSP across all the city blocks, and then when the packages are sold at the fulfillment center, they get slammed with the corresponding geo. So basically, we know that this package is gonna go in geo 3453. So now when that package arrives to the delivery station, we know exactly where to sort it, because we know that, where the geo that's gonna go. So basically we have bags that represent the different geos, and then basically we induct the packages to the geos. And then once we have all the packages sorted, then we run routing, but routing is a capacitated, routing engine, where basically we're gonna define the bags or the containers that are gonna go in each route. So we're no longer working at the package level, because once you put a package into a container and that container has 20 to 30 packages, nobody's gonna go and find an individual package to get it out of there. So now we basically route at the container level. And that's kind of at the high level what, how we do the high volume, network. But when we go to the specialized network, this is more kind of a full dynamic planning, because, these packages are sparse. So it doesn't really make sense to work in geos, because there are many geos where you're not going to have packages. So you're not going to create a grid to sort, for every geo where the vast majority are going to be impacted. Is going to be empty. So basically what we do is we do a full dynamic, planner kind of on the fly. Now, when I talk about inputs, there are many things that we care about. For example, buildings. When you tell me your address, and your address is 4543 Ball Ruler Way, apartment 403. And the next person give me the same address, but apartment 504. One of the jobs that we have is to make sure that we understand that the two addresses are in the same building, because then we can do building consolidation, right? So we care a lot about, making sure that we understand or we learn buildings. But when the people give me the address, they don't give me the building. They don't tell me, oh, this is the building X. I mean, in the States, sometimes we don't even have names for buildings. If you go to Latin America, people actually have names for buildings, but here we don't, right? So now we need to do the job to learn, how to consolidate, addresses into buildings. We also have to learn travel times. So, what it takes to go from A to B. That's something that we learn because we navigate through the streets, every day with many thousands of vehicles. And over time, we learn what it takes to go from A to B. We have to learn service times. Delivery at one of your houses is different than delivery at my house, or different than delivery at UT University, where all the packages have to go to the gym, right? So the delivery times changes by location. So as we do deliveries, we also aggregate all the information that allow us to create learning models that tell us, hey, in this house, the delivery is 2 minutes. In this other house, it takes 3 minutes. In this gym, it takes 10 minutes, whatever the case may be. We also learn maps. We generally, when we start a country, we buy some electronic map data. But the reality is that we have a much better ability to improve the map data over time. Why? Because our drivers navigate the streets. So every time a driver navigates the street and we see that the guy is navigating over a place that doesn't have a street, guess what? After 10 deliveries, we say, well, clearly there is a street there, right? So we also have learning models that allow us to kind of increase our maps. And then the geocode learning. And geocode learning, as I mentioned before, you know, you don't tell me your geocode, I learn your geocode. And how do we do this? You know, the drivers have an application that we give them, and when they deliver a package to your house, they are supposed to scan the package in front of your house. So, you know, we take the geocode of that scan, and that's kind of a first assumption of where your house is. The problem is that, you know, in your house over time, you will have 50 deliveries. And when we look at the geocodes, they may be in an area of, you know, 50 square meters. Why? Because the first driver went and he scanned it in his car. He didn't scan it at the door. The second guy went there and scanned it at the door. The third guy went to your house, you know, and scanned while he was walking through the door. So at the end of the day, we don't know which one is your house. I only know that I have 50 scans. So now which one is the house, right? So that's part of also the learning process that we do on learning exactly where your house is. But anyway, so what we do is basically we capture all the data and all the geotraces and all the pings from what we call the Rabbit application, that is the handheld device. On a particular day, we capture around 1.4 billion, you know, events during peak. We double that number, but basically we get, you know, all that information that basically boosts that learning models, and then that's why we're gonna, you know, be able to kind of learn, you know, all these different, you know, inputs. Now, let me show you what happens when you have the inputs wrong. These are two maps of the same city. What happened is that the maps have different granularity. If you look at the map on the left, I only have the 3 roads that are kind of surrounding this neighborhood. In the other map, I have the 3 roads, but also I have the building, you know, layouts and the internal streets, right? So what happens if I don't have the map on the right and I only have the map on the left is the following. And this is actually a real scenario. Because I don't have, these are all the deliveries that within that neighborhood on a particular day. And this is the route that we gave to the driver. Guess what? This guy basically said, I don't want to work for Amazon anymore. You know, when we told him it was going to take 10 minutes, it took the entire day to deliver. You know, but why this happens? Because we didn't have for this area of the city the detailed map. So when we don't have the detailed map and you only have these streets, then you have to snap these deliveries to the closest street. And guess what? Now all these guys get snapped to the same street. But when the guy goes there, he says, oh my God, what do you mean? So now he has all these geocodes in the middle and now he has to come inside. But we didn't have any way to optimize this because we believe that in routing that these were the geocodes. So, you know, if you don't get the right inputs, you don't get the right outcome. And this happens every day because, again, nobody tells us, you know, how the cities are created. There is not a national repository. In every country, it's very different. And so this is a key part of the job, is how to learn all this. The fourth thing is you know, is we want to think big and think global, you know, because what happens is that, you know, one thing is to master deliveries in the US, but we do deliveries, you know, across the world. We do deliveries in, you know, in Dubai, in Germany, in Japan, in Saudi Arabia, and every country comes with its own challenges. You know, talking about addresses, you know, like, well, you know, the addresses, you know, my wife is from Nicaragua, and they have an unstructured address system. What do I mean by this? The address of her house in Nicaragua is something like 2 blocks south of the Red Church. Like, what the heck, right? So now you need to go and say, well, if that's the address system, that's the address systems. How do we deliver successfully in that address system? So as we go through different, you know, countries, you know, we need to kind of address their needs. But part of what we do is when we put something in place, we think global. We say, you know what, this is not going to be only for the US. So we need to make sure that we are capturing the requirement from the get-go across the board, so that we, even if it's not, doesn't make it to the phase 1, you know, hopefully we don't create choices in the design that is going to have one-way doors, because then we're going to have to redo the systems. So we have a lot of challenges ahead. You know, now the whole topic of electric vehicles, you know, you may have heard in the news that Amazon ordered 100,000 electric vehicles. A lot of challenges with electric vehicles because they have a maximum range. You know, some of these vehicles have a maximum range of 60 to 90 minutes. Well, you know, 60 to 90 miles. Well, some of our routes are 120 miles. So now what do, right? We also have this whole concept of autonomous vehicle deliveries. That's an area where we kind of starting to do some progress on how to get some robots to actually do deliveries. We actually testing some of that right now in Seattle and Los Angeles. We also want to automate, how the delivery stations work. As opposed to the sortation and picking, with humans, how can we make sure that we have robots to do it within the facilities? We have a lot to do on rural deliveries. We focus on the deliveries, within the cities, and we leave the rural deliveries to third parties. So we sell to rural, but then generally we have FedEx and UPS or the postal service or whatever to do that. It's very complex because again, the level of information for that. So there's, but it's starting to grow. So now we're gonna have to do the rural deliveries on our own. So that's an area where we're gonna have to do a lot of innovation. But I'm gonna leave you here with a last video on one of the things that we believe in Amazon is like opportunities are found where most of the people believe is not possible. And I'll give you kind of a video of something that was launched in the last couple of years that has been very successful and quite a lot of innovation.
You already know Amazon is the easiest way to get what you need, like gifts for people whose birthday you've forgotten. As an Amazon Prime member, you'll now be able to use Amazon Key, a new service that enables in-home delivery. With the Amazon Key app, you can also grant access to the people you trust. Let's say you need to remotely manage guest access to the front door of your home, maybe to let in your dog walker, a friend, or maybe to let in a team of home cleaning ninjas. To get started, order the Amazon Key in-home kit, which includes Amazon Cloud Cam and one of several compatible smart locks. Have it installed by a pro, or if you're handy, install it yourself. Once installed, it's no problem if you're not at home. With Amazon Key, you can get your packages delivered just inside your door. You can track your delivery with real-time notifications, watch the delivery happening live, or review a video of the delivery after it's complete. Maybe you don't want your packages sitting out on display. Maybe rain is in the forecast. Or maybe you just need your mom's gift moments before she walks through the door. Because you're awesome.
One of the biggest challenges that we have had over time is to go and try to deliver into a house, and if the place is not safe, we cannot leave the package outside. And Amazon Key has been one of the breakthroughs through that to basically allow us to get the packages inside the houses. And this is an area where when we started that process, people said there is no way, nobody will allow you to get into their houses, right? And but again, this is where Amazon comes and say, well, we're up for the challenge. And they knew that, at that point in time, we have Airbnbs and all that stuff. And, some of the executives saying, you're crazy. Some of these places are giving the entire house to strangers. So how come I'm not going to, be able to open the door to put a package? So, but, it takes, having an open mentality and think differently to be able to kind of innovate in those areas. But with that, I'll leave it out to questions.
Thank you so much, Julian, for the wonderful talk. It was very nice listening to the immense complexity and the amazing breadth and depth of what your team does at Amazon. So yeah, that was really a great talk. So if anyone has any questions, please raise your hand so that I can have them talk. So yeah, thank you. Let me see. Okay, Afzal has a question. Can you please unmute and ask your question,
Sure.
Afzal?
Thank you so much, Julian, for your wonderful talk. I am going through few concepts in machine learning, and it's good to see some of the state-of-the-art, applications of that. I was interested in what you, as last mile delivery team, are doing for drone delivery in the future, and what is your strategy during extreme events like the recent winter storm in Texas?
Yeah, so great questions. Yeah, so let's talk first about the drones. I think that, like in everything, the drones have a particular kind of a use case, and the drone is what is going to allow us to do is to be able to deliver in people that need packages within 15 minutes or 30 minutes, being able to deliver via drone. And so I think that part of what is in question is, how many people are going to be willing to pay extra money to deliver in that amount of time. Because one of the challenges that we have with the drones is the scale, right? So, today we deliver, 250 packages in a van. And if you had to deliver those 250 packages in 250 drones, maybe, but then the question is whether actually going to be able to scale to that level and deliver 60,000 packages via drones. Probably not. And also, but because probably, I think we don't believe that at this time everybody is going to need their packages 15 and 20 minutes apart. But I think that the drones will really address that niche of products that are imminent, that you really need to have right now, and that people are willing to kind of pay the extra money. So I'll see it more as a convenience, more than a cost reduction or a scale. The event of in Austin is an interesting one. Because this is what happened in Austin is the things of the perfect storm, right? It's a city that is never prepared for winter, because winter never happens, and happens every 10 years, and suddenly everything happens at the same time, and you get into that situation. We do have a command center. Actually, the command center is based in Austin for the North America, where basically we track all the routes that happen, and we provide remediation factors for those, and we also have mechanism, and we prepare for the scenarios on how to react to these places. But the specific event Austin is interesting because one of the things that we don't want to put drivers at risk, right? So it's not only we have to kind of do the balance between, we want to make sure that we match the customer promise, but we will never do it at the risk of the drivers. So in that particular event, the streets were icy, there is not really the ice in trucks. The last thing that we want to do is to do deliveries, because even if, if we have to fail to the customers, if we attempt to do, good for the customers, we're going to put a bunch of drivers, at risk. So in those cases, we prefer to sideline the volume 2 days or whatever it is, to make sure that, the risk, comes, first, and have safe operations. And then what we will do is that 2 days after, we're going to bring a hulk of a lot of extra drivers to make sure that we can work through the backlog.
Interesting. So like you have reserve drivers that you can use in case of, higher working hours.
Yeah, I mean, we have a crowdsourcing system, right? Like the flex. So we have the people that run the vans, but in crowdsourcing we can increase as many as we want. Today I may order 100, tomorrow I order 500, and it's a matter of the pay, because in Austin we have around 5,000 flex drivers. Now only few of them, only 100 of them may work for day. But if we want to activate all of them, it's just a matter of you just start to move the pay scale until everybody comes.
Interesting. Thank you so much.
No problem.
We have another question from Jacob.
Yeah, hi. Thank you very much for your talk. It's very, very interesting seeing the theoretical methods applied already on land. And I want to point out, or I want to ask about the focus you have on global deliveries, not only in the States. So I was wondering things like, if you have a new algorithm sent over to you, brought up to you, that has, let's say, a 5% improvement in the delivery time, but relies heavily on the U.S. postal system, which would not scale for anywhere else on the planet, or at least places that are not highly structured. Would you think about deploying it, just try to grow up from it? That's my first question. And my second question would be, for taking this kind of high-level decisions, are these decisions taken by people based on experience, or is this level also studied by algorithms?
Yeah. Great questions. Let me answer first the second one, and then I'll ask the first one. I will say that in Amazon, pretty much 100% of the decisions are done by data. So, whenever we want to make a decision, the data speaks. We will never allow anybody to make a decision with no data on the table. So, we will collect the data and we will debate about the data, and then we'll make a decision, around it. I'm going to answer the question to your first question with actually an example, because, we on one end, I want to have, reduce my footprint in tech and try to have global algorithms. But sometimes we need to do something different, especially when the algorithms that we have may not work for other countries. Because, countries like US and Europe and Japan, they all have, very good, solid electronic information, and pretty much, all the algorithms that we have in place are common to those regions. Countries like India and the Middle East, very different. 3 years ago, Amazon bought Zook, that is kind of the Amazon of the Middle East. And, when Amazon buys a company, generally, that company operates on their own for a year or two, and while they actually transition to kind of the Amazon web. So Zook last year was the time to actually transition to the Amazon web. So, they used to have, deliveries manual, where basically they will rely on the experience of the drivers, that they knew, where each address and each building was, and basically was a 100% manual operations. So we said, well, we wanna launch, Amazon, and we're gonna do it the Amazon way. So our initial thought process is cool. We're gonna go and launch the same systems that we have in the US. But when we went there to talk to the people, it took us, very short time to say it's not gonna be possible, because one of the things that happens on our systems is that they are heavily reliable rely on geocodes. But in those countries, the geocode presence or people have not really captured geocodes at all. And also the addresses are people, when they go to their website, to the Zook website, generally what people will do is they will put, whatever address that, and what matters was kind of the district where they live more than the address, because once they say this building, the drivers will know what the building is. So people didn't worry about putting the full address. So now we have a lot of data that doesn't have geocodes, and that when we have piecemeal address information, and when we put that into our main systems, it's just not gonna cut it. So what we decided to do was to have, in a way, a graduation path. So we decided to create a whole new engine to support a MENA region that doesn't work on geocodes, and basically it works on addresses themselves. And basically we have repositories of libraries of buildings, and we associate buildings to districts, and basically have a routing system that is kind of on a cluster base, based on the addresses, as opposed to kind of the row system that we have for geocodes in North America. Now, what we expect, and we decided to build it because we said there is no other way to automate it from day one. But what we're gonna do is that basically we have a graduation path, because once we put that system into place, and now we can start learning, capturing the data, and then eventually we're gonna get to a level of information where we can say, cool, 2 years down the line, it's ready to graduate to the new technology. But also what we notice now is that this other system can help us to start up countries that are in a similar situation. So now we have seen that now we may have 2 technologies and have a graduation path depending on the level of information that is available.
Okay. Yeah, I get it. And if I may, sorry for extending this, but very quickly, if I could ask, do you ever, in your experience, have you find people coming from academia getting frustrated by the chaotic environment that real life entails, and going far away from the ideal suppositions we use for designing methods?
Let me see if I understand your question. Is your question about
Like
people from academia
well,
working?
yeah, basically like how well, if you found that people coming from academia find it difficult to adjust to practical applications as you have to go away from ideal scenarios.
Yeah, no, actually, my experience has been good. Actually, in the last 2 years, I have hired personally 2 professors that were in different universities that now working for me as a scientist in Amazon. The conversion is a little bit difficult with respect, especially on the code and at the scale, right? Because generally in academia, people do not code on a professional level. So the code capabilities, at least on my assessment, is kind of weaker than what we want. So it takes them a while to kind of really get the code, to the right level, and the ability also to switch from, solving a problem to optimality to solving a problem good for the scale, 2 different concepts, right? So kind of making that transition. But I think that, especially on the science side in Amazon, I love the way of thinking of academia, because that's really what all my scientists in Amazon do. They basically are thinking about how to solve the problem, how to formulate a problem, how to, get best out of the data that they have, how to build machine learning systems. So I think that I don't see that as a roadblock in any ways. I would expect that we will hire a lot more people over time from academia that will make that transition to be kind of good practitioners.
Cool. Thank you very much.
No problem.
Yeah, thanks for the question and the answer. Julian, do you have time for one more last question?
Sure.
Okay, yeah, actually a friend of mine is asking from YouTube. His name is Tony from Purdue. And I actually had a similar question. So he says, you mentioned assigning drivers to the same areas to build up familiarity. Do you also consider periodically changing their assigned area to prevent job monotony?
Yes, so give me 1 second. Hold on a second. Yes, we because one of the things that happen is that as volume continue to increase, then the jurisdictions within the stations changes, right? So like, for example, once I break, Austin into 2 because I have 2 different stations, but 2 years down the line, my volume doubles. Now I need to maybe create a 3rd station. So now the jurisdiction will have to change. So if I've had drivers in jurisdiction 2, maybe part of the jurisdiction now is going to go to, jurisdiction 3. So there is these resets that happen, over time, just because we need to start breaking, the map into a different way. So and it's painful because when people have to reset, in a way they have to kind of start all over again on learning a new area. And so we try to kind of minimize the damage, but yeah, clearly we do it.
Okay, yeah. Thank you so much for that. Finally, I just wanted to quickly ask you if you want to say anything about the collaboration you have with MIT and the competition you have, because the audience is students and they might want to register and participate in that challenge. So.
Yeah, awesome. Yeah, and I invite everybody here to participate. That's a program that we're doing with MIT, where basically we are seeking students to come up with new methods of how to solve what we call the sequencing problem. Routing has 2 components. If I have to route 100,000 shipments, one thing is to break the 100,000 shipments into 100 routes. But the other one is the sequence of the route. So this problem is on the second one. And the reason we kind of want to get help from many people is because generally we have solved these problems with more optimization-based methods. But what we have seen is that people not necessarily adhere to the routes because they look at different things, and some people are better experienced in some time of the city, and they know exactly what streets to go and how to when there is traffic, they want to go south to north as opposed to north to south and so on. So the thing is that we now want to learn how to sequence based on what people have done. So we kind of soliciting approaches of all kinds. Hopefully not the classical optimization approaches. We have done that forever. I want to see people to come up with a different set of approaches. So we have very good prices, and also we're going to have the top teams to kind of basically recruit, or have the opportunity to interview directly for my team in Amazon. So that would be a good opportunity if you want to join for Amazon to participate in that event and come up with great solutions. On top of getting a good opportunity for publication on top of a good amount of cash. But I gotta go. And
yes, thank you so much. I was just gonna say thank you.
It was fun for everybody.
Yeah, yeah. All right. See you sometime, Julian. Bye-bye. Thank you.
Okay. Thank you.
Thank you.
Thanks everyone for attending. I hope you enjoyed the talk. So the competition as such is available online if you just search for MIT competition with the last mile challenge. You should be able to find it. And I think the last day to register is today or tomorrow. So you might want to check that out if you want to take part. So yeah, thanks everyone for attending, and see you again. So at our next event, which is on Wednesday, which is an industry talk by ARM. And yeah, so hopefully you'll have a nice time there too. Thank you.
Thank you. Bye-bye.
Bye.